Good morning, and we have returned to the Radisson JFK Airport, Dolphy Gilpin, and we're in the session of the amazing 5x12 matrix and its application, circuit analysis. All right, quickly, let us now find delta for this 3x3 mesh circuit. Delta is equal now to 0.5 into 0.903 0310 minus 0.4 into 0.4 03 0010, and the 0 would be dominant here because you have to multiply, so this value would really be 0, and I've chosen these values so that we'll have easy computation, but note in real life that it might not be so. You know, just for the ease of computation, I've chosen these very small values of the resistance elements. So this would be 0, 0, so that would turn out to be 0, so I'm going to leave it out. 0, 3, that would be plus 0, 3 into 0.5, 0.4, 0.0 minus 0.3, and 0.9 into 0.5, 0.0, and 0.010, and plus 0.4 into minus 0.400 minus 0.310. 0.0 would make this determinant 0, so we're not going to write down that one. Minus 0.3 into, we're finding delta, 0.5 for this circuitry, 0.0, 0.4, 0.3, and last one is now plus 10 into 0.5 minus 0.4, 0.409. So okay, so delta, the determinant will be equal now to 0.5 into 10 to the 9, 90, and 2 minus make a plus, so that's give you 9, minus 0.4 into 10 and 4, 40, and 0 times that will be 0, plus 0.3 into 5 and 3, 5 threes is 15, and that's a negative 15, and 0 and 0 make it 0, plus 0.9, which is really 9. I'm maintaining duality of the paired numerics. 0.9, and 10 and 5 is 50, and 0 and 0 is 0. And this one is now plus 0.4, 10 and 4, that will give us a negative 40, and 0, and that is 0. And this one, minus 0.3 into 3 and 5, 15. And how much is this one? This is the second to last one. 0.3, 5 and 3, and 0 and 0. Minus 0.3, 5 and 3, 15. This is 4 and 2 though. We'll have 4 and 2. Writing so fast, 0.4. It has to be a 0.3. Yeah, this is the one, minus 0.3 into 0.5, 0.4, right? And 0, 0 and 0, 3. This is 0, 0. Going too fast and all right. So so that minus 0, 3 into 15, and this is 0, and the last one here would be plus 10 into 9 and 5, 45, and 4 and 4, 16, minus, give you plus 16. And so delta is equal now to 5 times 99 minus 160, 440, minus 45, plus 450, minus 160, and minus 50. That will be the value for delta. And that's equal now to 5 times 99, 5, 9, 99, 5, 9, 5, 45, 9, 5, 45, and 4, 49, 495. And we know that's close because 5 times that is like 100. That will be 500, less than 500, 495. Minus 160, minus 45, plus 450, minus 160, minus 50. And we can do that addition now. Okay, minus 160, minus 160 will be 320. Let's set it up in a rough column here. We get 495 minus 160, 45, 450, 160, 50. Or we take all the minus signs. Minus 160 minus 145 will be minus 205. Minus 205 minus 160 will give you 5, 6, minus 365, and minus 15, minus 380. So we'll take all the negative sign and we get minus 380. Minus 160, that's will give you minus 205, plus minus 160, will give you 5, 6, minus 365, minus 380. And we take all the positive sign, which is 450 and 495. 450 and 495. 9 and 5, 14, 4 and 4, 8 and 1, 945. All the positive sign is 945. And so we say no, it's 945 minus 380. 5, even 10 is 4, 6, and 3 from 8 be 5. So the positive 565 for this delta value. Delta equals positive 565. And so we say now that n, I1, will be equal now to, we replace the voltage value and find the determinant now, you replacing the first column by the voltage value. And so that will be 040903 00 minus 0310. The determinant of that, and we need only to find the determinant for the first row because this will drop out, the zeros will drop out. So we get now for NI1, which is the numerator value, is equal now to 480 into 0903 minus 0310, which is equal now to 480 into 90 plus 9 is equal to 480 multiplied by 99. So if I do my maths quite well, I will say that's equal to 480 multiplied by 100 minus 99. So that will give us 4800 minus 99. So that will give us now 4,701. No. So with 2 zeros you have to add to the 480. Multiply by 99. So that will give us now 48,000. Okay, let's quickly do it from a rougher column here. 480, 99, 0, 9872, 9981, and 788, 900, 9872, 9981, 88, 0, 2, 0, 88, 16, 17, 97020. And therefore, I1, current I1 now will be equals now to N I1 over delta. We have calculated delta, and so that's equal now to 97020 over delta, which is 565. 565. This has been a positive 565 from that. And we could use a calculator to do this. And so we get some value for the current I1. All right, when we return, we'll calculate current I2 and current I3. We'll calculate I2 will be the current for mesh 2 and I3 will be the current for mesh 3. And that will be equal now to, let me say now, I2 will be equal to N I2 over delta, and I3 will be equal to N I3 over delta. But we know delta to be equal now to 565. So the delta won't change, but the numerator value will change, or will replace now this, the second column of this determinant by 480, 0, and 0, and maintain this column and this column to find I2. And we replace the third column by 480, 0, 0 to find I3. So we're going to find I2 and I3.